So for chapter 9.2, we're looking at the central limit theorem for sample means and to describe the features of t-distribution. We're actually not going to do this second objective here. We're just simply looking at the central limit theorem. Now, the central limit theorem for sample means assumes certain conditions. The theorem assures us that the distribution of a sample mean follows an approximately normal distribution no matter what the shape of the population distribution. So here are the three conditions. When determining whether you can apply the central limit theorem to analyze data, consider these three conditions. The first is you must have a random sample and independence. Each observation is collected randomly from the population and observations are independent of each other. Secondly, you must have a large sample. Either the population distribution is normal or the sample size is large. Usually 25 is large enough. And thirdly, you must have a big population. If the sample collected is collected without replacement, then the population would be at least 10 times the sample size. It's very important for these conditions to be met. Okay? For the central limit theorem, it simply says if the three conditions are met, then the sampling distribution is approximately mu and sigma over the square root of n. Remember, this is the mean, and this is the standard error, because we're talking about sampling, okay? The larger the sample size, better the approximation. If the population is normal to begin with, then the sampling distribution is exactly a normal distribution regardless of the sample size. So let's look at some of the problems. From 9 to 16 in this chapter, or in the chapter homework, is related to chapter 9.2. Question 9, the mean age of all 602 used cars for sales in a newspaper one Saturday last month was 7.3 with a standard deviation of 6.9. The distribution of ages is right skewed. Okay. For a study to determine the reliability of classified ads, a reporter randomly selects 40 of these used cars and plans to visit each owner to inspect the cars. He finds that the mean age of the 40 cars he samples is 7.6 with a standard deviation of 5 years. So first they're asking about 7.3 and 6.9, which is related to the population of 602. So both of these are parameters. Since they're related to the whole population. And then 7.6 and 5 are statistics. Because they're related to the sample. So remember that we use Greek letters for parameters. So mu, the mean is 7.3. The standard deviation is 6.9. Okay, this is mean, standard deviation. And then we use regular letters for statistic. The value 7.6 is the S value is the mean, which is 7.6, and the standard error or standard deviation of the sample is 5. I'm sorry, I have that backwards, right? Yes, I do. Yeah. X bar, this is the mean. That is 7.6. And the standard error for the statistic is 5. Ooh, trick question, yeah? This is the parameter population. And this is statistic sample. All right, so next we want to see if the conditions are met. First, we're explicitly told for condition 1, we're told in the problem that the reporter randomly selects. So random condition is met. Next, we look at the sample size. Sample size is equal to 40. We know that the sample size has to be greater than 25. So that condition is met. And thirdly, we want to look at the large population. So 40 times 10 is equal to 400. And we're given the actual population is 602. So 400 is greater than 602. I'm sorry, 602 is greater than 400. So large population is met. Is met. So all 3 conditions are fulfilled for this sample. Therefore, based on all the conditions being sampled, it is a normal distribution. All right, let's look at another example. The mean age of all 2,536 students at a small college is 22 years with a standard deviation of 3.3 years. So again, pay attention here. This is mu. This is sigma. Okay, Greek for parameters. A random sample of 3 students is obtained. The mean is 23.1, so x bar is equal to 23.1, and the standard deviation S is 2.6. So we can go ahead and fill this out. We have 22.7, 3.3, 23.1, 2.6. Is mu a parameter or a statistic? So we knew that Greek letters population, okay, parameter is population, and statistic sample. Greek letters mu and sigma, and regular letters x bar and s. Now let's check the conditions. Okay, is it random? Oh, because this is found from the population. Yes, population. Now we're going to check conditions. First of all, condition 1, We are explicitly told that the sample is random. Yes, random. Sample size. The sample size here is given as 3. 3 is less than 25. Condition not met. The sample size has to be greater than 25. The third condition is the population size, large population to be exact. So 3 times 10 is equal to 30. 2536 is definitely greater than 30, so condition met. So because the sample size condition is not met, the large sample condition is not satisfied. So it's no longer a normal distribution. We have to go to the distribution they give, where it says that the population distribution is right skewed. Okay, follows the population distribution since CLT conditions not fulfilled. As a rule of thumb, when considering whether or not to apply the central limit theorem to a sample drawn from the population that is not normal, a sample size of 25 or more is considered large. Which of the following is not a condition? So remember your 3 conditions: random sample, the population must be greater than 10, the sample must be 10 times, at least 10 times, sorry, the population must be at least 10 times greater than the sample size, and the sample size condition must be met. So clearly the one that's not here, one of those 3 is the sample must be drawn from a population that is normal. Right? Either the sample is normal, either the population distribution is normal or the sample size is normal. The population must be 10 times any sample collected independently. This is given right at the start, these 3 conditions right here. Okay? Okay, now, so all I did was select, it has nothing to do with the population not being normal. The distribution has to be normal. Okay? What is the mean sampling distribution of the sample mean? Quite simply, the population mean. When computing the t-stat, one divides by an estimate of the standard error. Why does one not divide by the true standard error? And that answer is very, very straightforward, because in real life, one almost never knows the value of the population standard deviation. Okay, that's kind of a common sense question. What is the difference between a t-distribution and a standard normal distribution? T-distribution typically has thicker tails than the standard normal distribution. And finally, in the t-distribution, the degrees of freedom are related to which of the following? only the sample size. Only the sample size. I hope this helps. I gave you some of the answers here because we don't have a lot of time left to do this, okay?